The Anthropocene is a term that has gained significant attention in recent years as it represents a new geological epoch defined by the profound impact of human activities on the Earth's systems. The concept of the Anthropocene was first proposed by Nobel Prize-winning chemist Paul Crutzen and biologist Eugene Stormer in 2000, highlighting the unprecedented influence of human actions on the planet's geology and ecosystems. The term Anthropocene itself stems from the Greek word anthropos, meaning human, and kainos, meaning new, emphasizing the era of humanity's dominance. One of the key defining characteristics of the Anthropocene is the exponential increase in carbon dioxide levels in the atmosphere, primarily driven by the burning of fossil fuels. Since the Industrial Revolution, human activities have led to a staggering 50% increase in atmospheric CO2 levels, reaching concentrations not seen in over 3 million years. This rapid rise in greenhouse gases has contributed significantly to global warming and climate change, with 19 of the 20 warmest years on record occurring since 2001. The impact of the Anthropocene extends beyond just climate change, with biodiversity loss reaching alarming rates. Scientists estimate that species extinction rates are now 1,000 times higher than natural background rates, leading to a loss of biodiversity unparalleled in human history. Furthermore, the Anthropocene has also seen a dramatic increase in resource extraction and pollution, with over 300 million tons of plastic waste generated annually, much of which ends up in our oceans. These staggering numbers underscore the urgent need for action to address the challenges posed by the Anthropocene and transition towards more sustainable and regenerative practices to ensure the health and well-being of our planet for future generations. The concept of the Anthropocene marks a significant shift in our understanding of humanity's relationship with the Earth, highlighting the profound impact of human activities on the planet's geological and ecological systems. The idea of a new geological epoch defined by human influence is not only a recent development but has roots in the history of scientific thought and environmental awareness. The term Anthropocene was officially coined in 2000 by Nobel Prize-winning chemist Paul Crutzen and biologist Eugene Stormer, but the recognition of human impact on the environment dates back much further. In the 19th century, geologist Antonio Stoppani first proposed the idea of Anthropozoic era, suggesting that human activities were shaping the Earth's surface. This early recognition of human influence laid the groundwork for the concept of the Anthropocene that we grapple with today. The Anthropocene Working Group, established in 2009 by the International Commission on Stratigraphy, has been tasked with determining whether the Anthropocene should be formally recognized as a new geological epoch. The group is examining various geological markers, such as radioactive isotopes from nuclear bomb tests, plastic pollution, and changes in sediment composition, to pinpoint the beginning of the Anthropocene. One proposed start date for the Anthropocene is the mid-20th century, coinciding with the onset of the Great Acceleration, a period marked by rapid industrialization, population growth, and resource consumption. This period saw a surge in human activities that have had lasting impacts on the Earth's systems, from deforestation and urbanization to the mass production of plastics and chemicals. The Great Acceleration also brought about a surge in carbon dioxide emissions, with atmospheric CO2 levels rising at an unprecedented rate. Since the mid-20th century, global carbon dioxide concentrations have increased by over 40%, reaching levels not seen in at least 800,000 years. This surge in greenhouse gases has led to a warming planet, rising sea levels, and more frequent extreme weather events. The historical context of the Anthropocene underscores the interconnectedness of human activities and their consequences for the planet. It serves as a reminder that our actions today will shape the future of the Earth for generations to come, highlighting the urgent need for sustainable practices and global cooperation to address the challenges of this new geological epoch. Human activities have played a pivotal role in ushering in the Anthropocene epoch, characterized by unprecedented levels of human impact on the Earth's systems. One of the key drivers of the Anthropocene is the exponential increase in carbon dioxide emissions resulting from the burning of fossil fuels. Since the Industrial Revolution, human activities have led to a staggering 50% increase in atmospheric CO2 levels, reaching concentrations not seen in over 3 million years. This surge in greenhouse gases has contributed significantly to global warming, with 19 of the 20 warmest years on record occurring since 2001. The impact of human activities on the environment extends beyond just climate change. Deforestation, driven by agricultural expansion and logging, has resulted in the loss of approximately 7.3 million hectares of forest each year, equivalent to the size of Panama. This rapid deforestation not only contributes to habitat loss and biodiversity decline, but also releases carbon stored in trees back into the atmosphere, further exacerbating climate change. The rise of urbanization is another significant human activity shaping the Anthropocene. By 2050, it is projected that 68% of the world's population will live in urban areas, leading to increased demand for resources and energy. Cities are responsible for 70% of global energy-related greenhouse gas emissions, highlighting the need for sustainable urban planning and infrastructure. The mass production and consumption of plastics are also emblematic of human activities driving the Anthropocene. Over 300 million tons of plastic are produced annually, with only 9% being recycled. Plastic pollution poses a severe threat to marine life, with an estimated 8 million tons of plastic entering the oceans each year, equivalent to dumping a garbage truck of plastic every minute. The Anthropocene is also marked by the acceleration of species extinction rates. Scientists estimate that species are going extinct at a rate 1,000 times higher than natural background rates, leading to a loss of biodiversity unparalleled in human history. Human activities such as habitat destruction, pollution, and climate change are primary drivers of this biodiversity crisis. The Anthropocene is a testament to the transformative power of human activities on the Earth's systems, underscoring the urgent need for collective action to mitigate the impacts of our actions and transition towards a more sustainable future. The impact of the Anthropocene on the environment is profound and far-reaching, with a myriad of consequences that are reshaping the planet's ecosystems. One of the most alarming impacts of the Anthropocene is the staggering rate of biodiversity loss. Scientists estimate that we are currently experiencing a mass extinction event, with species disappearing at a rate 1,000 times higher than natural background rates. This loss of biodiversity not only threatens the stability of ecosystems, but also diminishes the genetic diversity essential for adaptation and resilience. The oceans, in particular, have borne the brunt of human activities in the Anthropocene. Plastic pollution, one of the hallmarks of our era, poses a severe threat to marine life. It is estimated that there are over 5 trillion pieces of plastic floating in the world's oceans, with devastating consequences for marine animals that ingest or become entangled in plastic debris. Coral reefs, often referred to as the rainforests of the sea, are also under threat in the Anthropocene. Rising sea temperatures and ocean acidification, driven by climate change, are causing widespread coral bleaching events, leading to the decline of these vital ecosystems. The impact of the Anthropocene is not limited to biodiversity loss and plastic pollution. Climate change, fueled by human activities such as burning fossil fuels and deforestation, is altering the Earth's climate at an unprecedented rate. The Arctic, in particular, is experiencing the effects of climate change acutely. The region is warming at twice the global average, leading to the rapid melting of sea ice and permafrost. This not only threatens the unique ecosystems and wildlife of the Arctic, but also has global implications, such as rising sea levels and altered weather patterns. The Anthropocene is also characterized by resource depletion and pollution on a massive scale. The extraction and consumption of natural resources, such as water, minerals, and fossil fuels, have reached unsustainable levels, leading to environmental degradation and ecosystem disruption. Pollution from industrial activities, agriculture, and urbanization further compounds these challenges, contaminating air, water, and soil. The cumulative impact of these human activities in the Anthropocene underscores the urgent need for concerted action to address the environmental crises facing our planet and transition towards more sustainable and regenerative practices. Biodiversity loss is one of the most pressing challenges of the Anthropocene, with species disappearing at an alarming rate. Scientists estimate that we are currently experiencing a mass extinction event, comparable in scale to the 5 previous mass extinctions in Earth's history. The current extinction rate is estimated to be 1,000 times higher than natural background rates, leading to a loss of biodiversity unparalleled in human history. It is estimated that up to 1 million species are at risk of extinction in the coming decades, representing a significant threat to global ecosystems and the services they provide. The impact of biodiversity loss extends beyond just the disappearance of individual species. Ecosystems rely on a diverse array of species to function effectively, with each species playing a unique role in maintaining ecosystem balance. The loss of key species can have cascading effects throughout an ecosystem, leading to destabilization and potential collapse. Coral reefs, for example, are home to a quarter of all marine species, yet they are under threat due to climate change and human activities. It is estimated that 75% of the world's coral reefs are currently threatened, with some regions facing the risk of complete coral loss by the end of the century. The loss of coral reefs would not only impact marine biodiversity, but also have significant implications for coastal communities that rely on reefs for protection and livelihoods. Climate change is a defining feature of the Anthropocene, with global temperatures rising at an unprecedented rate. The past 5 decades have been the warmest on record, with each successive decade warmer than the last. The year 2019 was the second warmest year globally, following the record-breaking year 2016. The Arctic is warming at twice the global average, leading to the rapid melting of sea ice and permafrost. Since the late 19th century, sea levels have risen by about 8 inches, primarily due to the thermal expansion of seawater and the melting of glaciers and ice caps. This rise in sea levels poses a significant threat to coastal communities and low-lying areas, with projections indicating a further increase of 1 to 4 feet by the end of the century. Extreme weather events, such as hurricanes, heat waves, and wildfires, are becoming more frequent and intense due to climate change. The economic costs of these events are staggering, with global losses from extreme weather surpassing $200 billion annually. The impacts of climate change are not limited to the environment, but also have profound implications for human health. Rising temperatures are exacerbating air pollution and respiratory illnesses, while changes in precipitation patterns are affecting water availability and food security. The urgency of addressing climate change cannot be overstated, as the window of opportunity to limit global warming to safe levels is rapidly closing. Resource depletion and pollution are 2 interconnected challenges that are exacerbating the environmental impacts of the Anthropocene. One striking example of resource depletion is the rapid decline of global fish stocks. Over 90% of the world's fish stocks are either fully exploited or overexploited, threatening the long-term sustainability of marine ecosystems. In addition to overfishing, habitat destruction and pollution are also contributing to the decline of marine biodiversity. Plastic pollution, in particular, poses a significant threat to marine life. It is estimated that there are over 5 trillion pieces of plastic floating in the world's oceans, with devastating consequences for marine animals that ingest or become entangled in plastic debris. The production and consumption of plastics continue to rise, with over 300 million tons of plastic produced annually, of which only 9% is recycled. This linear model of production and consumption is not only depleting finite resources, but also generating vast amounts of waste that end up in landfills and oceans. Pollution from industrial activities, agriculture, and urbanization further compounds the challenges of the Anthropocene. Air pollution, primarily from the burning of fossil fuels, is a leading cause of respiratory illnesses and premature deaths worldwide. Water pollution from agricultural runoff and industrial discharge contaminates freshwater sources and threatens aquatic ecosystems. Soil pollution from pesticides and heavy metals degrades soil quality and reduces agricultural productivity. Addressing resource depletion and pollution requires a shift towards more sustainable practices, such as circular economy models and renewable energy sources, to ensure the health and well-being of both the planet and its inhabitants. Mitigation strategies for the Anthropocene are crucial in addressing the environmental challenges we face. One key strategy is the transition to renewable energy sources, such as solar and wind power, to reduce our reliance on fossil fuels. In 2019, renewable energy accounted for over 26% of global electricity generation, with solar and wind energy capacity increasing by 20% and 10%, respectively. Another important mitigation strategy is reforestation and afforestation efforts to restore degraded ecosystems and sequester carbon. It is estimated that global tree cover could be increased by 25% without encroaching on agricultural land, providing significant carbon sequestration potential. Sustainable land management practices, such as agroforestry and regenerative agriculture, can also play a crucial role in mitigating the impacts of the Anthropocene. Agroforestry systems, which integrate trees and crops on the same land, have been shown to increase crop yields, enhance biodiversity, and sequester carbon in soils. In 2018, the global agroforestry market was valued at over $71 billion, with a projected annual growth rate of 9%. Additionally, reducing food waste is a key mitigation strategy for the Anthropocene. It is estimated that 1/3 of all food produced globally is lost or wasted, amounting to about 1.3 billion tons per year. Implementing measures to reduce food waste, such as improved storage and distribution systems, could significantly reduce greenhouse gas emissions and alleviate pressure on natural resources. Technology and innovation play a pivotal role in addressing the challenges of the Anthropocene. For instance, advancements in artificial intelligence, AI, are being utilized to optimize energy systems and reduce carbon emissions. In 2019, global investments in renewable energy technologies reached a record high of $288.9 billion, showcasing the growing importance of clean energy solutions. Additionally, the development of sustainable agriculture technologies, such as precision farming and vertical farming, is revolutionizing food production and reducing environmental impacts. The Internet of Things, IoT, is also being leveraged to monitor and manage natural resources more efficiently. By harnessing the power of technology and innovation, we have the potential to create a more sustainable future for our planet. The Anthropocene presents a critical juncture for individuals and governments to take action towards a more sustainable future. One striking fact is that the global population is projected to reach 9.7 billion by 2050, placing unprecedented pressure on natural resources and ecosystems. In response to this challenge, innovative solutions such as vertical farming have emerged. With vertical farms, using 95% less water than traditional agriculture and producing yields up to 30 times higher. This technology not only addresses food security concerns, but also reduces the environmental footprint of agriculture. Another compelling statistic is that air pollution is responsible for an estimated 7 million premature deaths worldwide each year. By implementing clean air policies and transitioning to electric vehicles, governments can significantly reduce air pollution levels and improve public health. Furthermore, investing in public transportation infrastructure can help reduce greenhouse gas emissions and alleviate traffic congestion in urban areas. Individuals can also make a difference through simple actions such as reducing meat consumption, which can lower carbon emissions and reduce deforestation associated with livestock farming. Additionally, adopting energy-efficient practices at home, such as using LED light bulbs and smart thermostats, can help lower energy consumption and reduce carbon footprints. Governments play a crucial role in setting ambitious climate targets and implementing policies to incentivize sustainable practices. For instance, the European Union aims to achieve carbon neutrality by 2050, signaling a commitment to reducing greenhouse gas emissions and transitioning to renewable energy sources. By working together towards a common goal, individuals and governments can drive meaningful change and create a more resilient and sustainable future for generations to come.